Yeah. I'll try to drag it out to you. I have time to get back. May 13th, the quadratic formula. Here's what I love about this lesson. Yes, there's some awesome algebra coming. And I'm going to hand you maybe the most powerful thing that I've given you this year. That's not why I love it so much. Why I love it is because a whole bunch of stuff that's been going on here the last month or so, where you're like, yeah, but what about this? Or how are you going to handle that? What are you going to do about this, Mr. Todd? Click. This handles all that stuff. Okay? Learning goal. I will be able to solve a polynomial equation by using a formula. Okay, well, let's just add on to that to be clear what I mean by that. I'm going to give something away about this lesson right here. Add this to your note by using a formula, not by factoring. This isn't going to rely on factoring. That's big. It solves the problem I couldn't factor it. It solves the problem it doesn't factor. It solves all of that, all in one swoosh. Now, it's a little complicated. Yes? It's a little complicated. Solving a this is all review stuff. This is like, where are we at here? Solving a polynomial equation means determine the value that makes the equation true. Find the x values that make this true. This value is often called the solution. Now, we're going to be focusing on degree 2s. So what we're doing today is quadratic. It means we're looking at things that are degree 2. What I'm going to show you works for degree 2. It doesn't work for degree 1. And it doesn't work for higher degrees. The solutions are often called the roots. And this is why my funny joke coming up, when people wear root sweaters in my class, I'll say, ooh, found a technicality to the no illegal sweaters thing, because you got a math sweater. Roots. Next year, if you're in my class, go get one. We'll make it a joke, and we'll cheat the uniform system. So, the quadratic formula. Here, write it in. I left a blank just because I'm so excited to write it. Quadratic formula. And again, we've established what that means. We won't have to factor to use this thing. Eliminating two problems. What if I can't factor it? And what if it doesn't factor? A formula for determining the roots of the equation of the form ax squared plus bx plus c equals 0. Now listen, friends, this is the most dangerous part of this. This thing only works once you've already got it in that form. It's got to be back in standard form. Because by the end of last week, you might have been like, why do we even do standard form? It's virtually useless. I like factored form. It did a lot of stuff for us. Vertex form was way better, although it's a little difficult to get it into vertex form. Complete the square is a bit of a nightmare. But quadratic formula says, no, get it into standard form first. The formula uses the coefficients of a, b, and c. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant term, or the number out there by itself, not on a variable term. And apparently, here's the quadratic formula. Here it goes. This is your first time. Oh, do you have to write it down? No, it's filled in for you. That makes me sad. X equals negative b plus or minus? Yeah, plus or minus b squared minus 4ac all over 2a. But you got that in your note, do you? Yeah? Oh, my writing isn't very neat there. I want that to be neater in the note. I want your note. Oh, there it is. I hid it under a square. Rectangle, actually. Really, Mr. Todd? Come on. Come on. Really? Yes, really. Now, I'm going to do something here. You don't have to write any of it down. You're not responsible for any of this, what I'm going to do here. I just want you to listen to the words I use. And as it's happening, maybe it would be better even if you closed your eyes as I was doing it. You're like, just listen to the things I say and see if a lot of it sounds familiar. A lot of the actual operations I'm going to do sound familiar. Say they give you an equation, ax squared plus bx plus c equals 0. Say you're given that equation. Now, what I mean by that is you're giving it an equation that's maybe it's 2x squared plus 3x plus 4. I'm not judging what these numbers are going to be. Any numbers you want, put them into the quadratic equation. And here's what I'm going to do to them. Very slowly here, to convince you that what I'm about to do here is using all grade 10 math. I'm going to use grade 10 math to build the monstrosity that you got on your page there. Here's the first thing I'm going to do. I'm going to divide both sides by the letter a. Sorry, by the number a, whatever a is. I'm going to first divide that out. What happens when I divide by a is the first term becomes x squared. The second term becomes b over ax. And the third term becomes c over a. And this side becomes 0. Again, don't get hung up on the individual things I'm doing, but just the words I'm using. I divided it by a. You know about dividing by numbers, and that's what I did there. Now, I've got a polynomial with a value 1. I'm going to complete the square. That's what I'm going to do. I'm going to take half of this b over a and square it. That seems really hard because it's a b and an a. I'll show you the steps over here. I'm going to go over here just like we did. And what you should be thinking over here if you're listening to me and following my advice is, oh, he's not, the b's and a's are a little confusing to me, but he's just completing the square. I know how to do this. Divide by 2 and square. So divide by 2 means this becomes b over 2a. Squared becomes b squared over 4a squared. I squared the numerator, I squared the denominator. Again, don't let the b's and a's muddle your brain. All you should get out of that, I don't know, maybe some of you can stick right with me, maybe not. But mostly what you should get from that is like, oh, he's just doing what we've been doing. He's dividing something by 2 and squaring it. And I'm using that. And I'm going to add that magic number, b squared over 4a squared, but then I'm also going to subtract it. And again, stay with me when I say that's just what we've been doing, add and subtract. I know it's b's and a's and c's and going everywhere. Looks like a big mess of alphagettis. Then I'm going to do what we did. I'm going to take that mess, that trinomial, and factor it. It's a perfect square. It's something, x plus something all squared. What's the something? It's this thing, b over 2a. That's what happened to us when we were doing complete the square. That number up there, when we wanted to factor it, when we got confused, was just this. And this stuff, I'm just going to move to the other side of the equation. The b squared, the negative b squared over 4a squared, it just moved over there, and the c over a, it just moved over there. Moving things over to the other side. Again, that's supposed to be the familiar part. The b's and the a's and the c's and the a's, yeah, I get that. That's all confusing. But it's just, if they're add over there, they're subtract over there. If they're subtract over here, they're add over there. Well, these things combine together, and those of you who've been relying on your calculator and who have been, with the fraction thing, are still writing decimals. When I marked your test, I circled when you kept decimals. And I gave you the full marks. I started circling them going, we got to get better with the fractions. You're like, why? Isn't the decimals okay? I'm like, yeah? Look here. Look at this disaster. You can't just punch that in your calculator and get the decimal. That's not going to work. You need to be able to get a common denominator. And the common denominator here is 4a squared. So I get, this is 4ac over 4a squared. I multiplied top and bottom by 4a. And actually, I did that fast on purpose to try to challenge you and make you go, there's a reason he's harassing us about fractions. It's so that when this moment comes up, you're like, yeah, common denominator. Multiply top and bottom by 4a. Now I can subtract those two really scary fractions. Things are good. Now I need to do the opposite of squaring. What's the opposite of squaring? Square root is true, but not complete. Yeah. let's say I told you that, I need a new letter. I don't want to use any of the letters that are in the question here. Let's say I told you z squared was 25. What could z be? It could be 5. It could be something else too. It could be -5. The rest of the story is, what we should be doing is when we do the opposite of squaring, we should be going plus or minus square root. Yee. That might be new information. We might not have beat that to death. Because we were doing it with Pythagorean theorem all the time, we didn't worry about the plus or minus. So when I do this opposite of squaring, I got to go plus or minus square root of this monstrosity. And do I have enough space to do one more line over there? Yes. There's a quadratic formula. But it can be tidied up a little bit. That square root of the top, I can't do anything with the square root of the top. So I'm stuck with the square root of the top. Square root b squared minus 4ac. But the bottom, I can square root and it becomes 2a. And look, they got a common denominator. That's luck. I didn't cause that to happen. That common denominator just happened. And here's the best version of the quadratic formula. That can all scare you. But don't let it. Really follow my advice and go, I did follow the words you were using. It's just grade 10 math with some crazy letters in it. I completed the square. I moved stuff over. I square rooted. And I got some common denominators. I can hear in the tone of my voice, like, oh, so it's so easy. No. Oh, no, I don't think that's easy at all. I think that's one of the most ridiculous things you've seen. Oh, that actually might be the most ridiculous thing you've seen in math so far. You don't have to do any of that. You don't have to do any of that. Here's what you have to do. An example comes up that is ax squared plus bx plus c equals 0. It's got to be in standard form. You label the a and b and c. The a is 2, the b is 15, and the c is 1. Then you memorize the quadratic formula, or use it enough times that you've got it memorized, or you buy yourself a t-shirt with the quadratic formula on it. Mr. Todd, they don't, what's that? Or get a tattoo. Mr. Yakimishin got his classes tattoos. I'm going to find out what he got from him. And then on the test, you can be like, that's a good idea. Eh? I'll ask him. I'll text him right now. Where'd you get those tattoos?
Where'd you get the shirt from?
What's that?
Where'd you get the shirt from?
My closet. Where do you get your shirts from? You ask questions like this. Where did you get the tattoos? I can show you the one I do have. No, I won't show you. Little pi symbol up there, yeah. Okay, I know it looks complicated, but let's pretend you had it memorized. Or let's pretend it was on the top of the page. Or let's pretend you had a t-shirt or a tattoo. And we'll fight about, as the test comes up, when we should memorize it. Because we've got to get it memorized at some point. I don't know when that is. Let's leave that on the shelf for now. Then it's just plug it in. The x's are negative, the b's 15, plus or minus, square root, the b gets squared, minus the 4 times the a times the c, all over the 2 times the a. Now, I don't know. If you take the memorization of this monstrosity out of it, you're just plugging the numbers in. Yeah? No big deal, I don't think. I don't think you should give this thing too much credit. You're like, bang, you just put the numbers in there. Now, you got some bedmass type stuff to do to simplify this, but that's not so bad. Negative 15 plus or minus. Okay, 15 squared minus 4 times 2 times 1. You got a calculator that can handle all that. 225 minus 8. I get 217. Somebody on the calculator case there to make sure I don't make any Is that right? And then 2 times 2, maybe, hopefully you don't need your calculator for that. It's 4. And this is where now we break. Once you've simplified what's in the radical, it's called, in the square root there, then you break into your 2 answers. Because quadratics often had 2 answers, right? And that's what the plus minus does. The plus minus says, yes, there's 2 answers here. There's a plus 1 and there's a minus 1. And so then you break these into 2 pieces. You go x equals negative 15 plus root 217. That's all over 4. Or x equals negative 5 minus the square root 217. And that's all over 4. And your calculator does the rest. You go 15, negative 15 plus root 217, and hopefully you got a calculator that does denominators. Makes it easier to type this in. Now, friends, if you don't have a calculator that does denominators, I'll bring one up on the screen that does. But then I'll do it as if it can't handle this situation, okay? And it's important to get your calculator out. And if you don't have your calculator with you, then tonight go back to this exact moment in the lesson and try to use your calculator to do what I'm about to do. There's essentially 2 types of calculators out there now, ones that display fractions and ones that don't. If you have a display fraction one, you hit the fraction button and you literally get a fraction. And maybe tonight's the night where you're like, okay, you finally convinced me. I'm going to break out with my old calculator. I'm going to get over to Staples or to wherever or onto Amazon and get one of these things. I got a couple of loaners too if it's time to switch over. Because if you have a fraction button, this is really straightforward. Negative 15 plus square root 217 all over 4, and I hit equals. The calculator at first, most calculators now, try not to do it. They want to leave it exact. And this has a lot to do with the fraction thing and staying exact. This question says, no, get the decimals. So you might have to hit, mine has a change button. Maybe yours is SD, S with an arrow to the D, or FD sometimes. It switched over to decimals here, and I get negative 0.067, because it said 3 decimal places. We should, when we round off, you should put a little dot over the equal sign saying, I rounded this off. There was more decimal places, but I stopped there. This is why this thing couldn't factor. One of the numbers was negative 0.067. Remember all those times like 2 numbers that multiply to 6 and add to 5. You're like, what are they? This time the numbers were like negative. Nobody's coming up with that without the quadratic formula. Yeah? Now, those of you who have the fraction calculator, don't retype it all in. Maybe you already started. You just arrow back, and you go up to that plus, and you backspace over it. You change it to a minus. Hit the change button, and I get the other one, negative 7.433. Mr. Todd, I don't have the fancy fraction calculator. Here's what you do. That will be different. When you do it on your calculator, you should do this. You should go negative 15 plus root 217 and find out what that numerator is. Press equals to get the numerator. Then you'll hit divide by 4. And then you'll get the answer I was looking for. You can use brackets too. Another way to do this is to put a bracket around the numerator. Negative 15 plus root 217. Close the bracket, and then outside the bracket, divide by 4. And you'll get the same answer again. So even if you don't have that fancy calculator, you can do it that way. If you want the fancier calculator, I think they're on every day on Amazon. Like they're not expensive to get one that handles all this. Amazon, Casio, FX 300 ES Plus. I loan them out to people all the time. Oh, it's on for $20.93 today. It has slipped over 20. Sometimes it gets down to 18. Yeah. So, but again, if you can't get one and you want one, you let me know. I'll give you one of my loaners. Okay. Any questions? It could be you're like, okay, You're scaring me on this formula about the whole memorization thing. That I'm worried about. But as long as I have it, I plug into it. And we'll fight as the chapter goes on and decide what the good move here is. I suspect the fact that Mr. Yakimishin has given his class tattoos means he's finding a middle ground. He's going, okay, we really do want you to memorize it. We want you to feel like you're cheating, but we're going to let you cheat. I think that's what the grade 10 teachers are up to. I can tell you as a grade 11 teacher, I laughed out loud. Like, are you going to give us the quadratic formula? I was like, no, there's no way. I am giving, it's just too important. In grade 12, in calculus, it just keeps coming. Right? Let's do another one. Because someone might be like wondering about some trouble that might happen here. And there is some trouble looming. What could go wrong here? Okay, well, anyways. Has to be in standard form, friends. This one is in standard form. If it's in standard form, the a is the coefficient of x squared, which here is a 1. Some of you are saying, oh, when there's no coefficient on x squared. I'm like, yeah, I didn't correct you, but now that's going to cause you a problem. What coefficient is on x squared? 1. The b is negative 6, and the c is 4. Hopefully that means like, okay, so I just plug those in. I got the formula, I just plug them in. Negative b, so this is negative 6, which is positive 6. You could just write positive 6. Yeah, Peter. Yeah.
Hi, Peter.
You don't have to. You can have them. Plus or minus, and now we've seen what that plus or minus means. The plus or minus means one of the answers is plus, the other one is minus, and we'll do that work in a second. And then square root, number one error is right here. Squaring that b means squaring the whole b. Negative 6 in brackets squared. Minus 4 times 1 times 4. Look, I'm really fast at it because I've done like a million of these. So I plug them in very quickly. You should practice enough that you can do it very quickly. And so my next line I get not negative 6, now it's positive 6 plus or minus root. I get 20. Anybody with me? Yeah. So I get my two answers. And I like little arrows here. That means x equals 6 plus root 20 over 2, or x equals 6 minus root 20 over 2. I won't say much. You practice putting it in your calculator to make sure you got this down pat on your calculator. Mine, I've got the fraction button, so it's really easy to type in and see. 5.236. Check that you're getting the same as me. And then I'm going to go back and change that to a 0.764. Yeah? So you punch it in your calculator and go, yeah, I can make my calculator do it. Maybe using one of my methods, you punched into your old style calculator and like, I got the answers, no problem. I don't think I need a new style calculator. Maybe, but the time's going to run out on those old style calculators. Eventually you're going to be like, I want to switch over. At this point in the lesson, you might be like, so every quadratic has two answers? We know that's not true. We know that's not true. So what's the quadratic formula going to say about that? I'm giving away maybe tomorrow's lesson. What's going to happen to make it so I'd only get one answer? How can plus or minus something be the same thing? What number can you add or subtract and you get the same answer? 0. So it could be some questions. What happens is you get square root of 0 and you only get one answer. No problem. Yeah? Okay, how can we get no answers? Square root of something and I don't get any answers. What kinds of numbers can you square root and you won't get an answer? 1 I can square root. 0 I can square root. I get 0. What will you try and square root And there's no answer. Decimals, I can square root any decimal I want. Here I go, let's try it in a calculator. Square root 57. Answer 7.54. Square root 0. Negatives. It's negatives. What's inside there might come out to a negative. And when that happens, your calculator is going to be like, no. And all that's saying is, oh, there's no zeros. It looks like a big problem. It's like, oh, it's one of those parabolas that doesn't have any zeros. So that's not going to be a big problem. Quadratic formula is like, I can handle all of that. Don't worry your pretty little head. It's going to be okay. Yes? Last one for today. Can you believe that? Quadratic formula in 25 minutes or less. You couldn't get a pizza that fast. I was like, I could have. Yeah. I guess I meant delivery. Yeah. Why is this one not yet ready? It's not in standard form. Okay, so I hope I made a dramatic big deal about that enough to go. Cannot start picking out the A's, B's, and C's until this is in standard form. And this one, there's a fair amount of work to get it in standard form. I gotta do that. Not just square the individual terms, friends. That's not how squaring of binomials works. You've got to do the FOIL thing. So I get x squared plus 4x plus 4x plus 16. Distribute the thing on the right. It's okay if those steps are going past you pretty quick, because I'm trying to stay on task with what we're trying to accomplish here. Get rid of all the brackets. Multiply them all out. Collect all the like terms. But then do one more thing. If it's going to be in standard form, everything to one side. Those terms have to come over, and maybe you're so good you can do it in one step, are you? You algebra hotshots out there. I'm going to show the extra step. X squared plus 6x plus 6 equals 0. Let me just double check I did that right, okay? X squared plus 4x plus 4x plus 16, 2x plus 10, x squared plus 8x plus 16, 2x plus 10, x squared plus 8x plus 16, minus 2x minus 10, x squared plus 6x plus 6. Take some time to check those before you punch it in the quadratic formula and find out something's wrong. Yeah? Yeah, standard form. So now let's not wait around till tonight to find out that you don't know how to use the quadratic formula. Now you try. I'll do it slowly so you can check as you go. If it really is, you're finding it difficult, you can look at mine and check as you go, but you try it. I'll find the other thing. What was I supposed to give you today? Sorry, children, I used up a lot of your trees today. Look at this pile of photocopying. Practice quiz. I found it. Ellie? I'll do the next step, and then we'll see if you still have your question, okay? Oh, okay. There's the next step for anyone who's checking their work, making sure they're quadratic formula master. I got the t-shirt from the t-shirt place in the Conestoga Mall in Kitchener. They can make up any t-shirt you want. You just go up there and give them a design. Beautiful place. Now they're going to have to pay me for being on the video here. I've given them a shout out on the video. Did you get 12 in the square root? Me too. Did you make this far? Okay, hopefully most people were able to punch in their calculator. Let me teach a little tiny bit of grade 11. A little tiny bit of grade 11 here. Because the calculator does something funny with this, doesn't it? It goes like this. You type it into your calculator, you go -6 plus root 12 over 2. And you press equals. Now, those of you who don't have the fancy calculator, it doesn't do this. But look what my fancy calculator does. It says -3 plus root 3. How's it getting that? Let me teach you a lesson from grade 11. Yes? I'll go up here in red. You don't need to copy this down. You don't need to worry about it right now. But what we'll do in grade 11 is we'll take this thing and we'll go, okay, that means x equals -6. And root 12, I can't square root without getting a decimal. But if I factor 12 into two things, maybe one of them could be square rooted. What two things multiply to 12 and one of them square roots? 2 and 6? No, that doesn't work. 3 and 4? 4. You could break this root 12 into root 4 times root 3. And what happens there is you get -6 plus 2 root 3, because I can square root that. And that's how they get their answer, -3 plus root 3, because they divided each piece there. There, now you don't have to be so scared of grade 11. Stuff like that. Cute little algebraic tricks. Yes? You don't care. All right. Equals. No. Change. X equals negative 3 decimal places. -1.268. If you wrote 67, come on. We've been rounding for a long time. 3 decimal places. And the other one, I'm almost done on a Monday. Change that to minus -4.732. Did you get that? Just for fun, add those two numbers together. Also not part of this lesson, but just for fun. Add those two roots together.
If you add the roots together and divide it by 2, would that give you the vertex? Or would that
Yes.
give you the center?
Yes. What is it when you add them together? -6 divided by 2 is -3, which is half of the 6. Yeah, okay, so it all, that's what I was talking about this lesson. It sort of comes full circle where you're like, oh, it all works together. This was the piece that was missing of the puzzle. Does that ever happen to you when you build a puzzle at home? One piece missing drives you all crazy all day. You get home, there it is on the floor. This quadratic formula is the piece. You're like, oh, everything doesn't have to factor. We've got the quadratic formula now. I'm going to Kitchener to get a t-shirt. I'll get it declared spiritware for you. Actually, I don't know if I can do that. I'll find out. Huh? Friends, do your homework. It's my job to make this look easy, but you got to go through it, yeah?